So we're gonna talk a little bit about our 3D printing program. This class is aimed more towards the guys that are just getting into 3D printing, or if you guys have your printer from the program and you haven't taken it out of the box yet, or you haven't figured out a way of how to use it, this class is aimed towards you guys. We're gonna talk a little bit about our 3D Labs program. How does it work? How you can access the files, which files are in there, which files are coming. We're going to talk about the materials that you guys need to use your printers, the benefits that you have on using a printer. So why should you start using your printer more and more? We're going to show you a little bit of the Bamboo software, how to use the slicer, and actually use those files and be able to get a printed part. And we're also going to share some tips to show you guys how to improve your printing experience for all of you that have started and are maybe struggling a little bit or could use a tip or two. We're going to share some of that as well. So why do we think you guys should use a printer, or you should 3D print your spacers? Number one thing to me is you save labor time. I know every time we propose the idea of printing spacers to new dealers, they're like, oh, I could do this stuff on my router and it will only take me 20 or 30 minutes, or I could do them on my laser, or I could just cut them on the CNC. And I get it that when you make a spacer like that, it might take you only 20, 30 minutes, and while a printer might take 4 or 5 hours. But when you're using the 4 or 5 hours of that machine, that's time that you don't have to use your hands at all. You can use that time. You free up that time to do other stuff, like run your wires, do your sound deadening, mount your amplifiers, do any other stuff. So that's why we encourage people to use the printers more and more for spacers, even if they take a long time. It's at the long run, I'll promise you will save a lot of labor time. It will also save costs. When you run a 3D printer, it has the Bamboo Labs printer have a power supply the same size as a PC inside. So the power consumption is really low. Also, the cost of the filament is really low. I'm gonna show you guys where I get my filament, but our average for printing a 6.5-inch spacer ranges between $1 to $2.50. So it's a really inexpensive way to get a spacer and also to deliver a better spacer that you will get with a regular laser or CNC or doing them by hand. Because when we're printing a spacer, if you guys are downloading one of our spacers from the program, they all have the same height as a factory speaker. When you're using a CNC or you're stacking plastic, whether it's out of a laser or routing by hand, you're always limited to the thickness of your material. You can find it in 1/4 inch, 1/8 inch, 1/2 inch, 3/4, it doesn't matter. You can never reach the exact same height as a factory speaker. So with our printed adapters, we can just measure the exact height of the factory spacer. We can use that same dimension, so we know the spacer is going to fit properly. It's going to sit tight against the grill. It's not going to hit the factory panel. We can also easily countersunk our speaker so that it's recessed inside the spacer. We can do a chamfer on the back to promote the airflow. Or for example, when your car has a 6x9 opening and we're doing a 6.5 or an 8-inch speaker, we can slowly make a smooth transition to taper between a round opening to an oval. So that improves the airflow and makes the speaker sound better. We can also do a countersink when we're using the factory's hardware to remount the spacer, so you don't have to use different hardware, or you don't have to make a thin flange just because the screw is not long enough. So we can overcome all those things that are a little bit harder. They take a lot more time to do any other way. So now we're gonna dive into how to use the Orca Downloads portal. For all of you that don't know what the Orca Downloads portal is, we created a program where dealers can access this database that we've been doing from all the manufacturers, or hopefully at one point we'll get all manufacturers in there. But you could easily open the website, log in with your password, and you can just select the brand, the model of car that you're going to use, and the speaker you're going to use. And you could just download a spacer that you could easily fit on your 3D printer. So you don't need to learn how to design a spacer if you're part of the program. You can just download the file, print it, and you can make sure that it's going to fit on the vehicle that you're working on. Currently, we have around 130 SKUs in there between different brands, models, and different spacers. In some vehicles, we have the same adapter for a 6.5 or an 1/8 inch, whether it's Focal or Gladen. When we're doing a dash speaker, we have it for either a tweeter mount or a mid-range, or for also we're doing them for the new widebands for Gladen now. So it's a pretty cool idea. I think I'm gonna show you guys, for example, if you're using the bamboo slicer, I'm gonna show you on the preferences where you can associate the 3MF files to Bamboo Studio, so that when you just download a file, all you have to do is double click on it and it will just open the slicer and show you the spacer already on the software and already on the perfect orientation. I'm gonna stop sharing my screen for a minute and change to web browser to show you guys really quickly how the portal works. So if you guys will go to orcadownloads.com, this is a page that you're gonna see. If you guys are already part of the printing program, either your rep or Nalaka should give you a password to access it. Let's say I go to Gladden 3D Labs. It's gonna ask you for a password. Once you enter it, now I have autosave the one for Focal, so I'm gonna enter here. You have all the brands and spacers. Let's say we go to Chevy, and I want to download a dash speaker for a Focal spacer, a 6.5. I want to, let's say I'm going to mount an 8 on a brand new Chevy truck. I could just click there, and that's going to download my file into my computer. I could just open that file straight on my Bamboo software, and it will be ready for printing. I change quickly back to my presentation. Can you guys see the presentation? Yes.
Yes, we can.
Yes, good. Thank you. So now that we talk about it, about how we can get those spacers into our printer, we're gonna touch base a little bit on the materials that we need. First of all, we need the plastic or the filament rolls to actually get our spacers going. All the printers come brand new in the box with some green filament. That's a PLA filament. You could use it for prototypes, for testing, or actually to make sure your machine works. But filament rolls usually come in 1 kilogram format, and they come in plenty of colors and materials. But the most important thing is you need to get 1.75 millimeter. That's the standard filament for bamboo printers and for most of the small format printers. We also need to get threaded inserts. All of our spacers are designed to use a threaded insert with a metric thread in there, so you could actually press those in. There's a cool video here showing you guys how you press those inserts inside the spacer, so you could have a machine thread for your speaker. Most of our designs use M3 and M4. M3 mostly for dash speakers, 3 inches, 3.5, and M4 mostly for all the 6.5 and 8-inch spacers. Some speakers like the AWM use M5 metric screws. So we get these from Amazon at our shop. You could just search threaded inserts for plastic, and the thread side M3 and M4, and you can just buy a bag. I think a bag of 100 is around $8 or so, or you should also buy boxes with little assortments of them. And the other thing you need, it's either a soldering iron, or if you want to get a little bit more fancier, you can get one of these drill presses that already comes with a soldering iron with different tips. So these different tips that you see on the picture, they all correlate to each size of thread. So you just put them and press the insert perfectly and make sure it's perfectly parallel to the spacer, so you don't end up with screws that are crooked and stuff. The correct name for that is machine heat set insert tool, which you could get a press like this, or also if you have a small bench drill press that you're not using anymore, you could repurpose that, just put a soldering iron on top of it, or again, Amazon is your best friend for finding those type of tools. So what next thing that we need, it's the types of filaments that we're gonna use. If you guys have dived a little bit into 3D printing and filament, you're gonna notice there's a bunch of different materials available, and we just wanted to give you a quick rundown on the materials that we think you should be using. The first one, and what you're gonna use the most, it's ABS, I would say. That's our go type in our store, and when you guys see spacers in our booth, that's what we print them with. ABS is as good as the ABS plastic you can find in sheets. It's solid. It's not the easiest material to print, but we're gonna give you some tips so you guys could get successful prints one after the other one. What you want to avoid 100% is using PLA. PLA, we only use it at our shop for quick prototypes. If we want to print something and make sure it fits, or we're printing something that is not going inside a car, you could just do it out of PLA. That's no problem. But if you're printing something that goes inside a car, never use PLA because it has a lower melting point than ABS. And when you leave a part made out of PLA on a top of a dash or inside a car, and then it gets really hot, when the sun hits the car, it might warp or deform. So you want to avoid PLA as much as you can for inside a car. Then we have PETG. We don't use this as often, but we still keep a roll of two in stock because it has a little bit more flexibility than ABS. When you make something out of ABS, if you're doing a tab, let's say if I'm doing a speaker mount or if I'm doing a mount for a wideband speaker for grading, which I need to click, if I print out of ABS, it will probably click, but after a couple of times, that little flexion will start putting stress on the part and it might eventually break. When you're printing something out of PETG, it has a little bit more flexibility. So if you're doing tabs or you need something that snaps in, like for example, this is a spacer for one of our Gladen wideband drivers. If you guys haven't seen them, those don't have a flange. Just trying to take it here to show you guys. These speakers don't have a flange, so they just click in. And we need a spacer. Speaker doesn't have a flange at all. And the mounting location need to have some tabs. If we print this out of ABS, it's gonna work a couple of times, but the tabs might eventually give and break. So we print that out of PETG, so then you can insert your speaker and just click it in. Hard to do while looking at the camera. That's what we use PETG for these type of spacers and also for tweeter mounts. ASA, it's the same as ABS, but it also has UV resistance. Let's say if you're not doing just spacers, if you're doing your radar or laser pods, or you're doing a camera mount or a bracket that is going to go outside of the car and it's going to get exposed to the elements, you're better off using ASA. It prints on the same temperature and the same settings as ABS. It just has that extra added UV protection. You also want to have some TPU, which is a flexible filament. We use that sometimes when we need a gasketing, some sort of gasketing between a speaker and enclosure. We have a huge gap that some foam wouldn't cover it. That's what we print a gasket of TPU. TPU is the same material that the engine mounts on vehicles are made of. So it's a really flexible yet stiff material. We also do that. Let's say if you're mounting an amplifier to a sub-enclosure and you need some sort of isolation, you can use that material to print some standoffs, and that will act as an isolation for vibrations as well. And then lastly, we have carbon fiber and nylon infused filaments. Those are the filaments, I would say, they're as rigid as it gets. We use those when we're printing brackets or we're doing amp rack mounts, or we need something that has a lot of rigidity. That's what we use those materials for. So bottom line is, I would say if I give the example of our shop, we might use 20 rolls of ABS every time we go to like one of PETG, ASA, TPU, or carbon fiber. We don't really do those. We don't use as many of those, but you always want to keep one roll in stock just in case you need to do any of these things. So now that we know which filament should we need, we're going to jump to the how to use the Bamboo software. The Bamboo software is a slicer software for the 3D printer. And this is basically what converts the 3D file that we're putting inside the software. It's going to tell the machine how thick do we want the spacer, how fast do we want it to print, how many layers should we be using, how high should the layer be. Think of it like the slicer is grabbing the object and it's slicing it in really, really paper thin layers. And it's going to tell the machine how each layer should be laid on top of each other, how the machine should move to create that spacer. It's the equivalent, if you guys are using a laser, this would be the equivalent to using Lightburn, where you transfer your file into Lightburn. Or if you're using CNC, this would be the equivalent of when you use VCarve to convert your drawings into a G-code file or a tab file that your machine could use. So when we open our software, and we're going to touch base on a little bit of all these settings, and then we're going to see it live inside the software. But when you guys open your Bamboo software on the left side of the screen, you have all the settings. On the top, you have the machine, and this, if you guys go through the setup of the printer and you tell them the machine you have, this will be the only machine that you have. But if you download a file online or you play with your settings, sometimes you might have different machines in there. So we always want to make sure your correct printer is selected. In this case, is the P1S with a 0.4 nozzle. That's a default that comes in the Orca program. You also want to select the bed type. Again, the standard bed type, it's the P1S is the texture PI plate. But if you change plates or you buy difference from Bamboo, you want to make sure you're always using the right one before you slice your file. You want to choose your appropriate filament. If you are using ABS, you want to create the setting that comes by default from Bamboo, heats the bed of the printer to 90 degrees Celsius. You want to create always a custom preset and set that temperature to 100 degrees. Otherwise, your parts could lift from the bed, especially if you're printing big parts like spacer. They could lift off the bed and you could get warping or failed prints. So you always want to create a custom preset and set your temperature to 100 degrees Celsius. Then you can create or choose a printer preset. The Bamboo Labs got it really well dialed in with the machines. You got really good presets to start with. The standard preset, the strength, the high quality presets, they all work just really, really good out of the box. You can still tweak them or create your own presets. Like I created my own presets for when I'm printing spacers. I have a certain amount of walls that I need, a certain thickness. I always have the enabled support. So every time I'm going to print a spacer, I just choose my profile. I hit print, and I don't have to worry about dialing every single thing that I always dial in for my spacer. But we're going to go over all that in a minute. So now that we got our printer set up, we should go a little bit about orienting our parts. This is a speaker adapter that is just laid on the bed of the printer. And as you guys could see, it's not on the correct orientation. The way the printer works, it's slowly depositing filament from the bottom of the piece and it works its way up. So we always want to make sure we have a flat surface. Our object is laid on the flat surface of the bed. So clearly not like the picture is showing. All the Orca Labs files should come pre-oriented. Every time we design a spacer, we send it to the Bamboo software, we lay it on what we think is the correct face and the easiest one to print, and then we save the file so that when you guys open it, you don't see a spacer that is floating in the air like this. But if you do, whether you downloaded a file or you created your own, and when you send it to the printer, it looks like this, this is how you guys orient the file. First, you click the object, so it's surrounded by that white corners. And then we have two ways of orienting an object. We either click auto orient on the left side of the screen, and the software again is pretty good on picking the right orientation, but let's say it doesn't, or you guys want to choose a different one. The icon right there that says lay and face, it lets you choose the face that you want to match against the bed plate. So let's say if we click lay and face on this object, you would see a white perimeter around the base. If you click that, then the slicer will lay the part flat like we want it to. So again, they should come pre-oriented, but maybe the first ones that we did or not, or if you guys download or create your file, you might run into this issue. This is how you orient your parts to have a successful print. Now that we have our part oriented, we're gonna go about the same. We're gonna use the same object as an example. The picture on the right, it's just a zoom-in version of that object. And that's a slice file that we just cut in the middle to show you guys the different settings and what each one affects. So in this case, we're using the strength profile from default on Bamboo, and we're just seeing all their advanced settings. Wall loops are the quantity of wall perimeters. So it's the yellow lines that you guys see on that picture. Those are the lines that are going to define how many walls the printer is going to create, how many times it's going to loop around the circle before it starts creating the infill, which is all that hollow structure that we see in red on the picture. On this case, it's 6 walls times 0.4 millimeters, because that's the width of the nozzle, and that's the default wall distance. It's going to equal a wall of 2.4 millimeters, a little bit less than 1/8 of an inch. So if you want more wall loops, we just increase the number 6 that you see on the screen. You can bump it to 10. The standard setting, for example, comes only with 2 walls. So it's a wall that is less than 1 millimeter thick. It's a really thin wall. top shell layers are the layers on top of the spacer. So that's defining where the printer is going to stop creating that hollow infill and it's going to lay top layers on that. You always want to get at least, I would say, 5 layers to create a solid structure. You got to think the same on the bottom layers. It's the same, but on the bottom. So let's say if I grab this spacer here, and this is the way I printed it, the bottom layers are going to be down there. It's going to create 5 solid layers before it creates all my infill structure, and then it's going to have 5 more layers on the top. You always want at least 5 layers on the top and on the bottom, because otherwise when you put your screws in, you might just compress and crash the print. So you always want to have at least that amount of layers. So once we find our outer perimeter, our bottom and our top perimeter, the rest of the print is considered infill, and it's that red structure that we see over there. And we can choose the density with a percentage and the type, the pattern that we're gonna use for that infill. So there's a bunch of other settings, but this is the most important as far as getting a successful and a strong adapter. I'm not gonna go over every adapter and every type of infill and density. We're just gonna give you, there's a quick picture that shows you the difference between all those. You could just practice on your own and see which one works best for you. Or you could just go, my recommended is, I always use gyro unless I'm really running low on time, and then I use cubic infill. Those are the only tools that we use. You want to avoid using the grid at all times. The grid, which comes by default, just create a cross pattern with a bunch of squares. You want to avoid using that setting, because the problem with that setting is the infill. When the machine starts creating the structure, the nozzle rides on top of the layer that it was previously created. So the nozzle starts dragging that plastic, and you will get eventually bent or just fall off the printer. So if you guys are using that, if you're okay with the factory settings, just changing that to a different infill like cubic or gyro will make your printer last a lot longer. Right here, we have an example using a honeycomb infill, the same spacer that we seen before. It's just on different infill patterns. Bottom left corner, 10% infill, 25% infill, 50%, and 75%. So as you guys could see, the more infill, the more solid the spacer gets. But I always, as I said, recommend avoid the grid. Guys could also avoid concentric for spacers, because concentric it just creates a bunch of circular words that they are not connected one to each other. So that's not going to give the spacer as much as rigidity as you guys want to. Now that we touch base on infill and density, we're going to talk about supports, brims, and rafts, why you guys should use it and when you should use it. Usually when a print fails, it's because it didn't have the proper support or it didn't have a brim or a raft. So we're going to explain the difference a little bit about them. So the brim, which is the blue area that you see on the left, that increases the bed adhesion. When you have a spacer, it would just create one layer of extra material on the bottom just to make sure it sits better against the bed. And it's good to use it on parts that have a really low contact patch with the bed. So if you're printing a small spacer, like a 3-inch or something like that, it's always recommended to add a brim. For a 6.5, it's not necessary, but it doesn't really hurt to use it. The machine doesn't really use much plastic, or it might take a minute or two more to do a print. So I always set the brim on the outside perimeter at least to guarantee that we're going to have a successful print. So what happens if you print a part and a brim didn't work, or you get a failed print? You could use a raft, which I always consider. I've never used a raft to print a speaker adapter, but I do it on parts that have really, really low contact patch against the surface of the bed. Let's say, for example, if you're printing a kick panel and you're going to lay it vertical, you're only going to have one thin layer of plastic sitting against the bed. You want to add a raft. In that case, the raft is just a platform that lays on top of the bed, and then the print lays on top of that platform. It takes a little bit more time. It's a little bit more messy, but you end up with better results. You get better adhesion and successful prints. Again, we don't use it for spacers, but I figure it's worth for you guys to know what it is and where you could use it. The other feature that you guys should always use is the support structure. The way the printers work, and I have this example here again of this spacer. As we said, they start depositing material from the bottom and they work their way up. If they run into a part like this, for example, that is floating in the air, the printer would have no way of printing all this because the plastic would just ride on the air and it would just start falling like you guys see in that picture. That's why we create a support structure, which is a little bit bridge of material that will just lay on the bottom of that so that the printer has somewhere to grab on where it's printing the parts that are floating in the air. Support structure are just generated by the slicer. You don't have to create them or you don't have to include them in your designs. So all we have to do when we are doing a print is just enabling the support. The Bamboo software does a really good job at detecting when a part needs support and it doesn't. Back in the day, you used to have to figure out the angle, the distance of the support, which support you were going to use to hopefully get a decent print. And nowadays with the Bamboo slicer, all you have to do is click it to enable the supports like you guys see on the bottom of the PowerPoint. Make sure it's, you can use either 3 or regular supports. That is up to you guys. 3 supports usually use less material, but they take a little bit longer to slice. Regular supports slice way faster. They just use a little bit more material. You can experiment with both. I personally use 3 a lot more because it cuts the printing time a little bit, and I use a little bit less material, but it's you can go wrong with either one of them. Okay, I'm gonna stop sharing the screen for a minute and show you guys what we just talked about on a live example. Change my window to Bamboo Slicer software. So if you guys have downloaded your files, you could just double click them and the printer, the slicer will open it. But if not, you can either click add here to add a part, or you go here to file and open a project. Either one is the same. So I'm just gonna add a file. And if I get, I don't know, this file right here, and I open it, as we said, the printer is gonna show it on the correct orientation now. For what we showed before, if I click the object and I hit here lay on face, let's say my object was oriented in this location and I didn't want it like that, I just click the face that I want to use, and that's the way you orient the part. And on this part, we chose that location because if we choose the other side, like this, and if I look behind, you will have to create all a support structure to fill the countersink of the spacer and also for the mounting tabs. We don't want that. We want to use as less support as possible, and we want to have as big as possible as a contact area. So we choose this location. As I said here, you have all your printer profiles. We always stick with the Bamboo P1S 0.4 if that's the printer that we have, our bed type. All of our filaments, the ones from Bamboo, the ones you guys could create. For example, this is what I use personally, Sunblue ABS. It's cheap and it works good. We buy it wholesale and we pay around $11 a kilo or $12 a kilo versus 25 or so that is on the Bamboo website. And last year we used a little bit over 100 kilos. So we use a lot and it works fine. It's inexpensive. So that's what we use if you guys want to try it out. We have all of our printer profiles here, as we said. And I'm going to show you an example with the standard profile, which is the default. I'm going to hit slice. And the printer is going to show me here that it's going to use 33 grams based on the cost of the filament that I inputted on the slicer. It's going to cost us 34 cents to do this spacer at that density. And it's going to take an hour and 14 minutes total. Now, if I zoom in, you guys are going to see that default setting, as I said, had that grid pattern where the nozzle drags on top of each square when it keeps forming all the infill, and that eventually makes it bend and just fail. So we want to avoid that. And if you guys also see, the walls are not that dense. We only have 2 walls. The yellow and the orange is the inner and outer wall. So if we're doing a threaded insert in there, we're not going to have enough bite on the plastic for the threaded insert. It might just spin when you insert it, and it's also not going to be as solid as I would recommend. But this is a fast way of producing a good spacer. If you guys change, for example, to the strength version, and we hit slice again, you see the density is a lot more solid. Infill has more density, you have more walls. Now it's going to take an hour and 45 minutes. It's a little bit more, but it's not as bad. I have, for example, custom presets that we use for, we have a lot more walls, we have a lot more density, and this is gonna take 2 hours and 27 minutes. Still gonna be cheap. It's around 66 cents of plastic. It's just gonna take a little bit longer to print. Now, going to what we said about the supports, I'm gonna lay this part the wrong way so you guys could see what the support structure does. I'm gonna look at this from the bottom. If I hit slice, first thing I'm gonna get is a warning on the system. It's gonna tell me that it has floating regions and I need to orient the object different or enable support to get a successful print. So I'm gonna hit support here, enable a normal support, and we're gonna see all that green surface right there. That support structure. Bring this out. So all that green stuff that you see there, it's the material that the printer is depositing to enable these top layers to sit properly and don't rest in the air. So it's, of course, the part is gonna take longer and it's gonna use more filament. So it's always recommended to just orient the part in a way that it doesn't need support, or you guys don't need as much support for it. Now that I slice my plate, if I have my file, I'm satisfied with my settings and I want to print it, all I have to do is click on the top right corner, print plate. And if you guys have one printer, it's right there. If not, you choose your multiple printers. You hit send, and the file is gonna go straight to the printer. If you guys have more than one printer, and let's say you're gonna print the same adapter front and rear on your car, and I'm making this up. You guys have a Honda, it uses the same speaker, same adapter front and rear. You need 4, and you have 4 printers. You can click here, and I'm sorry, I don't have it set up on this computer, but you could set it up as to send it to multi-device, and then you guys could send the same file at the same time to 4 printers. Okay, now I'm gonna stop sharing the screen and go back again to my PowerPoint one last time. Up. And we're gonna share some tips for you guys to have successful prints. The number one tip, as I said, if you're using ABS, it's set the bed temperature to 100 degrees Celsius. Default settings by Bamboo Labs, it's 90 degrees. The spacers are gonna end up warping on the ends, or they're gonna just unstick from the bed and fail. So that's the number one thing you gotta use if you're using ABS, just set the temperature on the bed to 100 degrees. Also clean that bed periodically. The ABS tends to leave a greasy residue on top of the bed, and after a couple of prints, you might see that the prints are not sticking as good as they used to be. We tried everything, our shop, glue, a bunch of different stuff when we were having problems, and it always gets fixed by cleaning the bed. I would say every 10 or 20 prints, you just clean the bed, you take it out of the machine, it's magnetic. You just scrub it with some IPL alcohol, some detergent, and then just rinse them with water, let them air dry, or use just a cloth that won't leave any residue on it, and they're good to go again. You can also use them both sides, so you can print 10 or 20 prints on one side, turn it around, then use the other side of the bed for another 10, 20 prints, and then clean them. But that's the number one cause of parts not sticking to the bed, is the bed not cleaned up properly. Also, when you guys are not using filament, you want to store it on vacuum bags. All the rolls of filament come on a vacuum bag from the manufacturer. Don't throw those bags away. They're like a Ziploc bag with a lock on the top. Just put the filament in there, put some of the silica bags that come with either the filament, or when you guys buy speakers from us, they also come with those parts. Just put them in there and store them inside the bag, because all these filament rolls absorb a lot of moisture. And if you have a roll of filament laying around, and if you live in a humid climate, if you leave it outside for 2 to 3 months and you're going to try to print, the print is not going to work well. It's not going to be the printer. It's more than likely going to be the filament. You could also get a filament dryer if you live in humid climates. I would recommend it. If you don't use the printers that often and a roll of filament ends up lasting you months, you can get a filament dryer from Amazon. They're inexpensive, they're around 40 to 50 bucks. And they're just, think of it like a small toaster oven where it's just slowly putting heat on the filament and it's drying it and bringing it back to its regular condition. So you can get one of those if you live in humid climates, you don't use the rolls that much. We tend to use a roll of filament at least every week on each machine, so we don't really have to worry about that. Plus, we're in California, we don't have that much humidity, but it's one of those things that it doesn't hurt to have one. Also, if you guys live at a really cold weather or you're gonna do a long print, it's recommended to preheat the bed 10 to 15 minutes before you start a print. You can do it from your phone. If you have the Bamboo app on your phone, you can log in, see your printers, and just preheat the bed. So, for example, if I'm driving to the shop and I know that as soon as I get there, I'm going to print some stuff, I just preheat the machine from my phone 10 to 15 minutes while I turn on my computer, turn on my lights, get my coffee. Once I'm done with all the stuff, the printers are already up to temperature and all the chamber is heated up. So it will give you a lot more successful prints if you do that as well. It will also reduce the time a little bit because when the moment you hit print on your computer, the machine starts to preheat and then it processes the file and everything. So if you got already the bed up to 100 degrees, you save a couple of minutes that way as well. Last tip would be placing the objects as close to the center of the build plate as you can. If you're printing a 6.5 round circular spacer, just place it on the center of the bed. Don't place it on one of the corners, because the problem with the heated bed is that the heat source is on the center of the plate. It doesn't have any heat source around it. So if you place an object too close to the bed, even too close to one of the ends of the bed, even if you see 100 degrees on the machine and it's telling you that the bed is at 100 degrees, it's not really 100 on the corners. So you might get a little bit of warping. You always want to make sure your parts are as close as possible to the center. Now, I know some guys still think that this is just going to take too long. It doesn't make sense because you guys are either a production shop or you don't have time to wait for spacers, because we all started somehow that way. I would say just think of it like you have another employee on your printer. Whether you're routing, firing up the laser, stacking plastic, doing everything, it just takes a little bit of time. It might not seem like a lot, 10, 15, 20 minutes, but every time you do a spacer, that really adds up. Well, the printers, you could just click clean. You could just click print and forget. You should also plan your schedule ahead. If you know that you have a car coming that is going to use 4 spacers and you already have created the file or you download it from the Orca website, you could start printing them the night before. If you have one machine, you're going to print 1 spacer at a time. If you have multiple printers, you could print 2 spacers or 3 or 4 at the same time. That also cuts your time a lot. Machines are inexpensive nowadays. You could get one of these P1S printers either for free from Orca with a qualifying order, or if you're going to buy it, it's around $600. So you could get a machine for really, really cheap, and you could get it producing parts right away. You could also leave them running at night. When we have long prints, we set them the night before. You know, a car is coming, just hit print and forget. Also, if you forgot about that or you still have to design your spacers, you can, good workflow is when you get the car at the shop, the first thing you do is you either design or set your spacers to print. You let them print. Even if it takes 5 hours and you have 2 printers, you know, it's going to take 10 hours to get the spacers. It's going to take 5 hours, don't worry. You could run your wires, you could do your sound ending, you can mount your amplifier, your fuse holder bracket, you could do all the rest of the stuff. And then when the spacers are done, you just put the speakers in and call it a day. If you do the rest of the install and then your last step is mounting a speaker and you're like, oh, I don't have the spacer, the printing is going to take too long. It's just, you're never going to be able to use them. You should plan ahead for all the time that machine takes. Also, if you guys are in a production shop or you need a lot of spacers, when you have the machine free that is not printing anything, just set it to print some spacers. If you know you work on a lot of Chevy trucks, or you know work on a lot of Ford trucks, or you work on a lot of European vehicles, or you do a lot of, I don't know, Volkswagen, whatever you do, just print a couple of spacers and hang them on the wall. Whenever you get a car, you might just have the spacer that you needed ready to go. It's actually cheaper to print the spacers than buy them from a manufacturer and hang them on the wall. So if you already have the machine and you have the plastic, it doesn't hurt to just keep some of them. And the last one, if you guys are doing a lot of production and you want your spacers quicker, you can change the default nozzle from 0.4 millimeters to 0.6 or 0.8. That's going to make your print deposit a lot of more material. So, for example, on what we used before, 6 perimeter walls to design a spacer, if we change the nozzle to 0.8, we're going to get the same thickness on only 3 perimeters instead of 6. So the machine is going to travel half of the time. Same, you're going to be able to create a thicker layer. You're going to lose resolution, but your spacers are going to come a lot faster, and they're gonna also be a little bit stronger because they have a lot more bonding between the layers. So if you guys are really into this and you need a way to cut some time, you can look into upgrading the nozzles. You can buy them from Bamboo. At our shop, for example, we have 5 printers. 4 of them have 0.6 nozzles, so we can print 4 adapters at the same time. And then we have one with a 0.4 nozzle where we do the tweeter adapters or the mid ranges or stuff that we need a little bit more detail. That's why we keep a 0.4 machine for that. And well, last thing is, if you guys are not aware, there's no way for us to get every single car out there on the database for you guys. But what we offer is, if you guys know that you have a car coming that you don't have the spacers, you want to see them listed, and you have a little bit of time, you can talk to Nalak or talk to your rep, and you can send us the spacers. We can design them, get them back to you, and while you guys do the rest of the install, we can give you the files for that car as well. Before then, we've done that already with a couple of you guys, but for all of you that weren't aware, if it's a car that you guys don't see listed, just reach out to us because we might be able to give you that solution, and then also other dealers won't be able to have that same solution for the future. Thank you, guys. I'm gonna go to the chat screen and say if we have any questions, you guys could type them there. And we had a question: do the printers we got on promo as CF